So today's friend, we have to discuss about the haloalkanes and haloarenes. So let's talk about the haloalkanes. Haloalkanes. As name suggests, we know that haloalkane is made up of two words, right? The first one is halogen and the second one is what? Alkane. So as I think this one is very easy, everyone know this. Halogen is what? Fluorine, chlorine, bromine, iodine, acetylene, etc. Now alkane is what? You know, the hydrocarbon which has formula CnH2n plus 2, right? Like of course methane, ethane, propane, methane, ethane, propane, butane, etc. Look, now in case of haloalkanes, what happened? Suppose we have alkanes like methane, CH4, and we know that carbon attached with the 4 hydrogen atom. Now here it is, we have to remove one hydrogen from it and add one halogen. We get like CHHH and then the chlorine, which is methyl chloride, yani CH3Cl, right? This one is what? Methyl chloride. So what I'm trying to speak here, you know, carbon is tetravalent, of course. It forms 4 bond. You have to remove one hydrogen and add one halogen like fluorine, chlorine, bromine, and then we get haloalkane. So simple, right? Now again, what do you mean by the haloarenes? Let's talk about the haloarenes. Haloarenes is of course halogen and then the arenes. Now what is arenes? Arenes is like benzene. Okay, this one is arenes. We have to remove one hydrogen from the benzene and attach one chlorine, fluorine, bromine. Like this one, we have to add one chlorine here. This is chlorobenzene. This is chlorobenzene. Fluorobenzene, iodobenzene, right? This one is haloarenes. Of course, like we can say one halogen attached at the arenes. So this is haloarenes. Now this is common things which we have to discuss about the haloalkanes, haloarenes. Now we have to discuss about the classification, right? We have to discuss the classification of haloalkanes and haloarenes. Okay, here it is, classification. Look, classification of haloalkanes can be done on the basis of number of halogen atom. Okay, so now the first one is monohaloalkanes. What? Monohaloalkanes. So as the name suggests, what do you mean by the monohaloalkanes? You know, the haloalkanes having a single halogen, having single halogen, like methyl chloride, C2H5Br, ethyl bromide, like C3H7 iodine, propyl iodide, etc. This one is what? Monohaloalkanes. Of course, compound having a single halogen atom. Now the second one is what? Dihaloalkanes. Of course, in case of dihaloalkanes, a compound in which two halogen atom, I'm writing here, two halogen atom attached. So simple. Okay, so when two halogen attached at the single carbon atom, getting what I'm trying to speak here? If two halogen atom attached at the single carbon atom, then we call it geminal. We can of course classify it geminal as well as vicinal. And the second one is vicinal. Look, in case of geminal, like two halogen atom attached at the single carbon atom, like C, two carbon atoms, H and the H, chlorine and the chlorine, right? Two carbon atom attached at the single carbon atom. Now, in case of vicinal, what happened? Like two chlorine or two halogen atom attached at the two consecutive carbon atom, like CH3Cl, single bond CH3Cl. Oh, I'm so sorry. Here it is CH2Cl. CH2Cl, and again here it is CH2Cl. Now this is vicinal. So simple, है ना? When two carbon atom attached at the different carbon, two halogen attached at the different carbon, we call it vicinal, and the two chlorine, two halogen attached at the single carbon, this is genuine. And of course we can classify it as tri-haloalkanes. You know, the three halogen atom attached. So simple. So now we have to discuss about the main things, which is the preparation of haloalkanes, right? So let's discuss the preparation of haloalkanes. So student, we have to discuss the preparation of haloalkanes. Okay. Look, there are multiple methods by which we can prepare haloalkanes. Now, in syllabus, we have to discuss the first one is halogenation. Halogenation. In halogenations, we have to take few things. The first one is alkane. Methane, ethane, propane, right? And the second is halogen. All right, fluorine, chlorine, bromine, iodine, as well as acetylene. Now alkanes, halogen, and now this reaction is considered under sunlight. We need sunlight. So in sunlight we can write it as H nu, as we know, kind of energy present in the sunlight, which is H nu. So let us talk about the reactions. And after that we have to discuss the mechanism of it, right? Look, alkanes we have considered like methane. Now methane is react with the chlorine in presence of H nu. I'm simply writing H nu. Now we get methyl chloride, CH3Cl, right? Now one thing. Now this reaction is unstoppable, right? Now we know that in reactions we have surplus of chlorine. Now again reactions further move on in presence of H nu. The another molecules of chlorine react with it, form CH2Cl2, which is dichloromethane. Now this reaction is again moved to the chlorination. In presence of H nu we get CHCl3, which is chloroform, and now this reaction is again further moved to the chlorination H nu, unless we remove all carbon atom. Now this is tetrachlorocarbon. This is the final product. So we can say that this reaction have disadvantage. So what kind of disadvantage it has? Multiple product are formed. Okay. Look, now we have taken one carbon compound, right? So what happened? We consider like ethane and propane. Now CH2 CH3, right? Now in case of propanes, what we get? Look, what we get in case of chlorination, what we get? Product. The first one is CH3 CHCl3, and the other one is CH3 CH2 and then CH2Cl. Sir, what we are getting? Look, we get two product because we know that multiple product we get in these reactions, of course. Now the question arises here, which one is major and which one is minor. Now look, now this one is 3-degree carbon, right? In organic chemistry, we have already studied about many times. We know that 3-degree carbon is more stable than the 2-degree as well as than the first degree. So here it is, we can say that this one is major, this one is major. Why major? Because it is 2-degree carbon, and now 2-degree carbon is more stable, so that's why it is major. If we consider it prepare at 55%, then we get this one is at 45%, right? Now this is minor, right? This one is minor. So that's the method by which we can prepare haloalkanes. What I'm telling you, halogenation is process by which we can get haloalkanes, of course, but multiple compound are also formed, right? If we have to prepare like suppose you have to prepare methyl chloride. So now suppose you have to prepare methyl chloride. So what will happen? You get methyl chloride along with chloroform, along with the tetrachloride tetrachlorocarbon, along with the dichloromethane, right? So what I'm telling you, this is not the perfect, this is not the perfect method by which we can prepare haloalkanes, right? So we have multiple process by which we can prepare haloalkanes. Let's discuss one by one. And so firstly, we have to discuss the mechanism of it, right? We have to discuss the mechanism of it.